Google Cloud Storage is a very convenient place to store files for your projects, especially if you use the Google Cloud Platform. In this video, we will introduce how to use gsutil and the Python client to manage Google Cloud Storage buckets and files directly in the console and programmatically in Python. gsutil is part of the Google Cloud SDK. You can open this link and install it accordingly for your operating system on your computer. And to manage Google Cloud Storage in Python, we need to install the Google Cloud Storage API client library first, preferably in a virtual environment. After the Google Cloud SDK is installed, we need to authenticate it so we can use it to manage the buckets and files in our cloud storage. Run these commands in the console to authenticate gcloud. Check your console and solve potential issues when the commands are run. As to the Google Cloud Storage API client library, the easiest way to authenticate it is to set the environment variable Google_application_credentials to a JSON key file of a service account that has the storage admin role. After that, we can create a storage client in Python without any other authentication. Before we get started running commands, let's first understand two most important concepts first, namely bucket and blob. A bucket is a logical container in Google Cloud Storage that holds your data objects. It serves as the root namespace for the objects and must have a globally unique name across all of Google Cloud Storage. In comparison, a blob, which is short for binary large object, represents an individual piece of data stored within a bucket. Especially, an instance of the blob class in Python is the interface to work with files stored in Google Cloud Storage, as will be shown soon. Now let's create a bucket with gsutil and the Python client, respectively. We can use this gsutil command to create a bucket in the console. MB here stands for make buckets. Don't forget the gs:// prefix for a bucket to make it work properly. We also specified the storage class and location, which are optional. If omitted, the default settings would be used. The corresponding Python code is shown below the gsutil command, which is very straightforward. Now, let's upload a file to Google Cloud Storage. For gsutil, it's very simple. It's very similar to the cp command in Linux. In Python, we need to create a bucket object first, which is in turn used to create a blob object. We can then call the upload from file name method of the blob object to upload the file to Google Cloud Storage. Note that the blob name and the local file name are set to be the same in this case, and they are normally the same in practice. However, it's not mandatory. They can be different. In practice, it's very common to upload some binary content to a blob directly, without saving it to a local file first. This can be done with the upload from string method. For example, we can download an image from the web using the requests package and save it directly to Google Cloud Storage using the upload from string method. In practice, you may want to convert the image to a common format before saving it. To upload a folder, it's recommended to use the rsync rather than the cp command with gsutil, because the files can be uploaded more efficiently, especially when there are a large number of files in the folder. In Python, there is no way to upload a folder directly, and we need to upload the files one by one. Note that we don't need to create the folders and subfolders on the Google Cloud Storage in advance. They will be created for us automatically based on the file path. You can watch our previous video regarding how to use the pathlib module to manage file system paths in Python if you don't know the pathlib module. The code for downloading a file from Google Cloud Storage is similar to that for uploading a file, just the direction is opposite. Similarly, in Python, the download to file name method is used to download a file from Google Cloud Storage. The boilerplate code for creating the bucket and blob is the same. The gsutil code to download a folder from Google Cloud Storage is also similar to that for uploading a folder. Note that the -d option can be dangerous. It will delete the files that exist in the destination folder but not in the source folder. However, in Python, the code to download a folder from Google Cloud Storage is much more complex. Unfortunately, there is no way to download a folder from Google Cloud Storage directly, and we need to download the files one by one. Worse still, we need to create the subfolders manually as well. Nonetheless, if you read this code snippet, it's actually pretty self-explanatory. It also shows that the pathlib module is very convenient in managing path in Python. We can download the whole bucket or just a folder in the bucket. When downloading a whole bucket, the remote directory is set to be empty. Also note that when downloading a folder, the ending / must be present for the remote folder. Otherwise, files with the same name but outside the folder will also be downloaded. So far, we have covered the most complex parts of uploading and downloading a folder in Python. The remaining parts would be much easier. Firstly, we can rename a blob in Google Cloud Storage with the mv command of gsutil and the rename blob method in Python. Secondly, the gsutil command and Python code to delete a file in the bucket are also very similar to previous cases. Note that for the delete blob method, the file name is specified. Technically, it should be the file path in the bucket. Finally, let's check the command to delete a folder in the bucket. As expected, the rm command of gsutil is used. However, unexpectedly, the Python code to delete a folder is actually much simpler this time. We just need to get all the blobs in the folder with the list blobs method and then use the delete blobs method to delete all of them in one go. In this video, we covered various aspects of working with Google Cloud Storage. In summary, we can use gsutil to manage buckets and blobs directly in the console, as it can be much simpler than with the Python client in most cases. On the other hand, we can use the Python client when we need more flexible and programmatical management. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content.